So the presentation will be split in 4 parts. The two first parts about CAP'2ER tools, the methods, and dairy farm results in different systems in France. Then we will have a round of questions. Then a part about implementation in dairy farms and economical compensation with carbon credits. And we will finish with a last round of questions. So the first part about CAP'2ER tool. So some methods. The principal method is to use the life cycle analysis. That means measuring the environmental impact of a product through its life cycle from the resource used to create the product across its use by the user to its final end-of-life destination. So it's the principle of LCA. But here, in CAP'2ER tool, we will only do it at the farm level. So this part, because 90% of the impact of a liter of milk is on this part. And the second reason is because it's a tool used with farmers and to build action plans, and farmers have only action at their level and not about the processing, for instance. So we calculate at the dairy cattle level, for instance, and because LC analysis is to calculate impact of the product, there are two products in dairy cattle, the milk and the meat from heifers and cull cows. So we do an allocation. It's biophysical allocation according to the energy requirements between the dairy cows and the heifers. In average, this allocation is 74% for the milk and 26% for the meat. But it's calculated for each farm, so it can be a little bit different. The system boundaries of CAP'2ER. So as I said before, LC analysis is done at farm level. We take into account the inputs, so the concentrate, forage, fertilizer, fuel, and electricity. And so we have CO2 references behind it. Then we calculate what is happening in the farm, so with enteric fermentation, methane emissions, manure management. So it's the emission in the building or in the storage, so with methane and nitrous oxide emissions. And then we have the nitrogen fertilization, so with emission during the spreading, and direct energy emissions with CO2 emissions. And as I said before, there is an allocation between the milk and the meat. The CAP'2ER tool is an environmental analysis tool. So we calculate greenhouse gases emission, but also other environmental indicators like air quality and water quality. So the unit is kilogram nitrogen per hectares. Energy consumption with direct and indirect energy, and the unit is megajoule. But we have also positive contribution because the goal of the tool is also to show the positive impact of dairy farming, and we have 3 indicators. Carbon sequestration, so it's calculated with references of carbon sequestration of grassland and edges. The conservation of biodiversity, so it's with edges, trees, forest, border of river, for instance. We calculate this conservation of biodiversity. So instead of calculate to measure the number of flowers, insects, we calculate the habitat of this biodiversity. So the unit is hectare equivalent of biodiversity. And the last indicator is food performance with the number of fed people per year. The tool exists in different animal categories. So for dairy, beef, goat, sheep, and crops. And it will be soon available also for pig and poultry. So the tool has two levels. So level 1 is the easiest one, is cattle level with 30 input data. So it's more like an educational tool to sensitize farmers to this topic. And the level 2 is at farm level. So if you have dairy and crops, we take everything into account. It's 150 input data, and it's a tool to evaluate and to build action plan. So the tool is now available in different languages with possibility to have local references and parameters. So you can see the different flag of the available languages right now. So this slide is to show you some results of CAP'2ER. So there are 10 or 12 pages of results. So just to give you an overview of 2 pages. So you have one page, there are results at farm level with the result of environmental impact of the farm, with on the left part the positive contributions, on the right part the environmental impact. So it's the same indicators that I talked about before. Then you have figures about the GHG sources at the scale of the farm, so we are farm level. So this scheme this figure is educational for the farmers to explain what are greenhouse gases emission, what type of gases, where is it coming from, what are the percentage, what is important, to also talk after about the action, what will have an impact or not. And then you have a page about results of the dairy cattle. So we change of scale with the net carbon footprint. And you can see the color graduation. So I have a comparison to references. So in the tool, it's Inosis references. It's a French national network of commercial farm to build technical, economical, and environmental references. And the different references that for the dairy part, they are built according to the percentage of maize in the forage system. And then you have a description about the GHG emission and carbon sequestration and about the different sources, and with also comparison to references to help identify where the farmer is too high, for instance. And I didn't put it there, but we have also a page with technical indicators that talk more to the farmer than the environmental one. And so it's to help the farmer and the advisors to interpret the environmental result and to identify action with the technical indicators, like milk per cow or concentrate, stuff like that. Then we will look at different farm results in different systems in France, so in plain system and in mountain systems. So just to explain the results I will talk about, when we talk about emissions, it's the sum of the three gases, so methane, nitrous oxide, and CO2. And when we do emission less carbon sequestration, you have the net carbon footprint. The expression is in kilo equivalent CO2. To calculate it, we use global warming potential. So for CO2 is 1, 27 for methane, and 273 for nitrous oxide. That means that the methane, for instance, has a warming effect 27 times higher than the CO2. And there is a biophysical allocation that we talk about. So I will present only result about the milk part because it's the main part of dairy cattle. The boundaries of the system, we take into account dairy cattle, forage area, and the crops farm consumption. So the results are coming from the analysis of the database CAP'2ER level 2. So it's 7,300 diagnoses. We took only one diagnosis per farm. And so you have the distribution of the diagnosis in France, so it's mainly in the north and west part of France. You have the average farm, so it's 120 hectares on the 414 livestock units. And you have the main crops on the farm, so it's half grassland, permanent and temporary, and half maize, quarter maize and quarter crops. So the milk carbon footprint, the average of the CAP'2ER French farms, French dairy farm, it's 0.86 kilo equivalent CO2 per liter of milk. So it's not the average of the French farm because farms of the database are not chosen to be representative of the average French farm, and so the average is a little bit higher, in fact, the real average of the French farm. DHG emission, it's on 1, so kilo equivalent CO2 per liter of milk, and carbon sequestration is 0.15. So, in average, 15% of the emission are compensated by carbon sequestration. If we focus on the 1 kilogram emissions, where is it coming from? At the dairy part scale, half of it is coming from enteric fermentation, so it's really the most important part. Then you have 17% for manure management, so that's emission in buildings and manure storage. Linked to that, you have the 11% for fertilization. It's emission during the spreading of manure, organic fertilization, and mineral fertilization. And then you have all the input, so 9% for the feed, 3% for the fertilizer, and 6% for fuel and electricity, and 1% for animal purchase. So if you want to sum up, we have 70% of the emissions that are due to the cattle, either enteric fermentation or manure or animal purchase. And you have 30% that is coming from feed production, so either the forage or concentrate, buying concentrate, or use of fuel. So 30% for feed and 70% for the cattle. No, some results in plain systems. So to explain the chart, you have the GHG emission, so it's the sum of the three gases. Carbon sequestration, that is calculated with references behind the hedges and grassland. And net carbon footprint, that is the difference between emissions and carbon sequestration. And the tricolor is the tree system with grass, mixed and maize system. So it's according to the percentage of maize in the forage area. So grass system, if you have less than 10% of maize, mixed between 10 and 30. Maize system, it's above 30% of maize in the forage area. On the graph, you can see on the emissions that there are little differences between the systems, so it's not significant. So yeah, there are no differences between the systems. However, when you look at the carbon sequestration, there are big differences because the part of grassland and edges are not the same in these systems. And that explains why the net carbon footprint is significantly different between the three systems due to carbon sequestration. So, there is no important difference in emission between the systems. However, if we look at it for each system in the system, there are a high variability. So, for instance, in maize system, you have 19% of difference between the average of maize system and the top 10 of the system. So, there are a lot of work to improve within a system. So, in the mountain system, the results, it's quite the same. Just maybe something to have in mind that the emissions are a little bit lower due to a bit higher due to a lower productivity. But yeah, no big difference between the system, but an important difference between the system for carbon sequestration. So due to the part of grassland, percentage of grassland on the edges. And so the net carbon footprint is quite different between the two systems. So the lowest carbon footprint that we have is the grass mountain system with 0.7 kilo equivalent per liter of milk. So to finish on this part, when we do the diagnosis, then we talk about mitigation actions. The first action that has the most important impact is air management, because half of the emissions are methane emission due to enteric fermentation. So the action can be increasing the productivity, reducing the number of unproductive animals like heifers. Then you have the action about the feed, so to work on feed efficiency, forage quality and quantity. Then action about the input, to decrease the input, so we can work about pasture management, concentrates on fertilizers, legumes, crop rotations. We have also action about manure management, so with less time spent in shed versus pasture, with investment in biogas plants. Action about crop management and fertilization, so to put legume fodder crops, so to reduce mineral fertilizer and concentrate, and the optimization of fertilizer uses. And the last one is about fuel and electricity, with no-till cultivation, power on equipment, and organization. Okay, so this is finished for the first part of the presentation. So there is a question about the carbon sequestration. So we have references behind grassland, edges, and etc. So for instance, for 1 hectare of permanent grassland, it's 570 kilo carbon per hectare and per year. For the edges, it's 125 kilogram carbon for 100 meter of edges. We have also references for enteric crops, and temporary grassland. So these references are coming from scientific work. They are in the tool since 2013, and so there are a lot of work right now to try to update them, so that will change maybe in 1 or 2 years, I don't know, because we know it's maybe not, there are maybe some things to adjust, but yeah, for now it's the references that we have in the tool. Okay, so if there are no more questions, we'll go to the next part. So it's about the implementation in dairy farms, to give you an overview of what we are doing in France. So CAP'2ER tool was created in 2015 during this project, Carbon Dairy project, and it's really the project that was the beginning of this big adventure, where we built this tool and built references. And since then, we have other projects, so in other animal production, like beef carbon for beef production, green sheep, and now also project in with goat. And so, as to now, we reached the 30,000 diagnoses. So it's diagnoses are not farms, because some farms had several diagnoses, and we have more than 1,600 trained advisors from different organizations that can work with farmers on this subject.
So as I said before, the tool is used in dairy, beef, sheep, goat, and crops, and soon also for poultry and pigs, and it's also used at European level. So for the dairy production, the dissemination goes through a large partnership. At the national level, the initiatives are supported by the French dairy sector in the large scheme called la ferme laitière bas carbone, so the low carbon dairy farm. So it's to have a national scheme with goals. So the goals of the dairy sector is to reduce the French carbon footprint of the dairy cattle of 20%. And so behind the goals, they have different actions to put into place. And so these actions are done with a lot of different organizations. So the dissemination and the advice work is done with a lot of different advisory organizations. So it's the 1,600 trained advisors that I talked about before, so from different organizations. And we have also dairy companies that are involved a lot also to advise farmers on this topic. But another important part is the financial support to pay for the advice, the diagnosis. We have also a lot of finance, so coming from regions, but also the dairy companies that pay for the diagnosis. And so how is it done in farms? So this is an example, it's not always like that, but this is an example about a 3-year improvement process. So we have the first year, we have the CAP'2ER diagnosis, then we have the action plans. So the advisor built with the farmer an action plan, so they choose together which action the farmer is ready to put in place. The advisor calculates the technical impact on the farm, environmental impact, so the percentage of reduction, and also the economical impact to be sure that the farmer is winning. And then to help the farmer, there is a technical visit, so the farmer chooses the subject if they want about grassland management, effort feeding. So one of the actions that are in his plan. And so the second year there is a follow-up visit. So it's to make a review with the farmers. So what action did he put into place? Did he have difficulties? Did he need help for something, etc. And then there is a second diagnosis, the third year. So to see the farmer reach the initial goal. So this was about dissemination, and we are more about the improvement process and the technical improvement of the farm. But to help along the process, there is economical compensation with carbon credits to motivate farmers to enter this kind of scheme. So the carbon credit in France, it's with label bas carbone. So it's an official label. The goal is to have a scheme to foster the emergence of projects that go beyond regulation and usual practice. So it's go beyond what is required. The label certifies the quality and the impact of the project, and also it attracts funding towards this project. And this is really important. To enter the label, we need a method that is certified. So in France, it's called Carbon Agri. So it's a French methodology to certify GHG reduction in agriculture. So how it works? You have on chart the baseline scenario. So it's like the initial diagnosis of the farm. If you do nothing, it will go like that. You have a project scenario, so it's with action plans, the reduction of the emissions. And you have the crediting period, so it's a 5-year period. So we calculate the difference between the baseline scenario and the project scenario, and it is the emission reduction, and it is the carbon credit. So this is this part, the green part. So the method is certified, and the process is certified by the ministry. So carbon agri is a scope that concerns cattle and crop productions. There are other methodology for crops, forest, methanization units, and a lot of other things. And so the methodology is approved by the French Ministry of Ecological Transition. So for the farmer, how it's going? So first there is an audit to define the baseline. Then there is an action plan to build the mitigation action and to evaluate the decrease of emissions. Then the farmer applies the mitigation measure, and 5 years later we do the second audit to quantify the real CO2 reduction compared to the first audit. Then we verify and certify the carbon reduction, and at least the farmer is paid for the carbon reductions. So the payment is really done about the real results done on the farm. So in terms of timeline, so it's involvement during 5 years. So in the first years, the farmer do his first diagnosis and the carbon plan, where he chooses different action, the choice of practice, the different objectives, and we calculate the carbon gains. So for instance, it can be 400 tons, we calculate. The project is validated by the ministry. In the third year, there is a mid-term review. It's to assess the practice put in place to see if all is going well or if there are some problems. And if all is going well, there are part of the payment, 40% of the payment is done to the farmer. So if we calculate it 400 tons at the beginning, the farmer is paid 40% of 400 tons. And at the end of the 5th year, there is a final diagnosis. So we calculate the real reduction of emission between the two diagnoses. There is a verification audit by an independent auditor. And so we calculate the credits, and there is a recognition of the carbon credits. And the farmer will have the final payment. If the farmer, we calculated, for the example I gave, if the farmer at the beginning we calculated the emission reduction of 400 tons, and at the end he only did 300 tons, he will be paid only for the 300 tons. But he don't have to give back money or anything, he's just paid for what is really done. So what are the feedbacks about the credit carbon in France? So it began in 2020 with the first project. It was really the test project with 300 farmers. The second one was last year with almost 1,000 farmers. So with this project, we have, so it's an estimation because we don't know yet if they will do it, but we have an estimation of 1,000 ton CO2 reduction. And we have a third project on the way, so it's right now, with 1,700 farmers involved in this project. So to be a little more concrete about the reduction, so in average, with the two first projects, we have a reduction of 13% of carbon intensity. And so on a 5-year project for a farmer, it's around 450 to 600 tons of carbon reduction. The payment is 30 euro per ton for the farmers. So in average, it's paid 12,000 euro for the whole project, the 5-year project. But it depends a lot of the farm and the action plan on the farm. So it can go to 100 tons to 1,000 tons of carbon, so the payment can be quite different. And to finish, who is buying all this ton of carbon? So a lot of different companies. It can be banks, luxury companies, agri-food industry, restaurant chain, energy company, cooperative, and it can be small company, like regional company or international companies. And they have a lot of purchase criteria. It can be farm location. So often if you have a regional company that is in the north of France, for instance, they want to buy tons coming from farms in the north of France. They have also expectation about practices. So often they want action about grassland or edges. So the difficulty is that we don't have so many farmers that want to work on that. Okay. They have also criteria about co-benefit and also type of production, milk, meat, etc. And at the end, do you have a question about the dissemination about the carbon credit? Maybe all very clear. No question. Okay. So the presentation will be on the R4D website. So if you miss something or you want to look at it again. And so don't forget the next webinar on this project, so the 31st of May, about the mitigation action in experimental farm, if you want to learn more about it. And I thank you all for your attention. And see you another time.